So I believe that before break we were talking about problems of identity, and in particular the problem of the ship of Theseus. Does anyone recall how that problem arose, of the ship of Theseus? Yes.
The idea being that over time the ship has replaced most of its parts so that the structure of the ship is no longer integral to the beginning of the ship. So the question is it actually the same ship even though all of the inherent parts are the same?
So let's see. So we start out on Monday, say, with a ship that has certain parts, like a plank A and a plank B and a plank C. D and E. So it's got these 5 parts. And so this is ship A. And then in another place we have ship B, which is a lot like ship A, except it's made of different parts. It's in a different place and so on. So on Monday we have these 2 ships, and this ship is made up of X, W. This is made up of, say, V, W, X, Y, and Z. Okay.
So you replace all the old parts with new parts?
So on Monday this is the situation, and on Tuesday we decide one of these planks is not ship shape, so it has a defect in it. So we replace it, has a crack or something. So we replace it with plank V from over there. So we pull out A. So then on Tuesday we get a ship, which seems to be the same ship as we have on Monday. We just replaced one part for maintenance purposes. So this one will be made up out of V and what? B, C, D, E, right? So it'll be, take one of the planks out of that ship, the V plank, and put it in here. And then the other parts are the same. B, C, D, and E. And then on Wednesday, we decide, like, B is getting a little faded there, so we put in W for B. And still, it seems like that the ship on Monday is identical to the ship on Tuesday. Just like if you have a table and the corner gets chipped and you put some filler in there, you still have your original table. So this one's going to be made of VW, C, D, E. And then on Thursday, we're going to pull out C and replace it with X, and so on. Meanwhile, these boards we're pulling out still exist, so they'll be put in a pile over there, scrap heap, A and B and C and D and so on. So eventually, So see, on Monday, so 5 days later, like I guess on Saturday, right? We're going to have over here a ship made of VWXYZ, which is identical with the ship that was originally made of ABCDE. Okay. But now we can gather up those discarded planks, ABCDE, the discarded ones in the scrap heap, and put them together and have a ship which is made of ABCDE. So what are we to say? Which is the ship we started out with? Is it the one that is made of ABCDE, which is what we originally had, or is it this ship VWXYZ, which is now over here? So that's the problem. Which is the original ship of Theseus? Is it this ship that has completely different parts than the original ship of Theseus? Or is it the ship made of the discarded planks, which has exactly the same composition as the ship of Theseus had? And it can't be both. Okay. If we say that each day the ship retains its identity, then by the transitivity of identity, we have to say that the ship on Saturday is identical to the ship on Monday. On the other hand, if we may want to say that the ship that we make out of the discarded planks is actually the ship of Theseus, because it's made of ABCDE, which is what Theseus' ship was made of to begin with.
So you could argue that the actual ship of Theseus is just all the planks that you've like discarded out of the ship.
And well, once you put them together, yeah. Once you put them together to make a ship, yeah. Because it's not a ship until you put them together, right? It's just a pile of planks.
It's interesting because like with the house, you could say that like a house's foundation is what makes it the same house, but with the ship it like moves in water, so it's so different.
Mm-hmm. True.
So it's like, which is the same ship?
Yeah, that's the question. Which is the ship? What do you think? Which is the ship? It seems like the ship has an identity crisis here.
Right.
It's very puzzling, right? So if we say that the ship retains its identity through these minuscule changes, and of course you could break it down to 100,000 changes, right? Mm-hmm. If you want it to be more gradual. So that each tiny little change of a nail or a tiny little piece, it doesn't change the identity of the overall ship. Like if you get a new spark plug for your car, it's still the same car, right? But what after all the parts of your car have been replaced, after like 12 years of like replacing parts in your car, you may want to say that's my car. Or you may want to say that the car built out of the discarded parts of your car 12 years later is actually the car that you started out with, and that's your car. Leaving aside issues of ownership, we're talking about metaphysical identity. Of course, the car you own is the car that grows out of the car you originally had. You don't own the discarded parts because you threw those away and somebody else took them, and now they own them. Right? If possession is 9/10 of the law, then whoever gathered them up, right, and made the new car, turned them into a running car, I guess owns that one. But the question is not of ownership, but of metaphysical identity, which is the numerically same car, the one that Leibniz's law applies to, right? Says that it's actually numerically one and the same as the car you originally had. Is it the Saturday, the car that evolved out of the original car by gradual replacement of planks, or is it the car or ship that's built out of the discarded, thrown away parts that has the exact same composition as the car you started with. So it's a puzzle.
Does this work with like the human body as well?
Oh, that's a good question.
Like at what point are you the same person if your like bones keep growing, if your skin and your hair nails they grow and they fall off, your
Yeah.
blood?
I think like 7 years, something like that.
Yeah.
It's something like 7 years. Yeah, you're right. Like all of your bones in your body is like
Yeah, like
completely
every
new.
cell is, dies and you get reborn. Well, not
Mhm.
reborn, but you know what I mean.
Do nerve cells count?
I think nerve cells. I mean, in some
I
places,
think they,
some parts of your brain, nerve cells regenerate, but not others. So,
It may be that some cells in your brain like live for the whole lifespan of you. But the issue is not cells. It's parts. I mean, cells are parts, but they themselves have parts.
Yeah.
So a cell can change its parts as well,
right.
even if it's the same cell, since it's made of molecules which engage in metabolic and chemical processes. They're also changing. So it's hard to say exactly if any. The question is, are there any numerically identical molecules actually
that's true
in your body? And no one really knows, but I suspect there may be some DNA in your brain which is there for your whole life. Numerically the same DNA. That's the same all the way through.
if we go with that route, with the cell replacement and everything, we all technicality, as atoms aren't, destroyed or reborn, they're all the same. So technically we can use the same atoms to recreate, new cells. So we technically still be the same person.
What's also interesting is like specifically with like the human genome and like DNA is that DNA is still like subject to corruption. Like the telomeres after aging periods, like they get shorter and shorter, so they're not able to wrap around the DNA.
Yes.
So there's more room for error. So like skin cancer forms and stuff
Yeah.
like that. So like when you have things like that, does it still qualify as the same body, even if your genetic information changes? So imagine if you go under like radioactive issues and like your cells are like now mutated, are you still the same person as when you were born?
Well, okay, so to one point, we probably should distinguish same person question from same body question.
Oh, that's good. Yeah.
I mean, I think on the one hand we have to say there's a question about whether a given human animal is identical with another human animal, and then there's a question about whether a human person is identical with another human person. It may turn out that those are the same question if a person is identical with his body.
Right.
But only if a person is identical with his body are those the same question. If a person is somehow separate from his body, then the question of personal identity and the question of bodily identity are two different questions. So we don't know. You might imagine cases where you don't have the same person, but you have the same body, like imagine the story of Dr. Jekyll and Mr. Hyde, that kind of thing. Same body, but two different persons, one a monster and the other really nice person.
with like,
Right? So there is that. If you're a materialist, the two questions will collapse into one. There won't be a difference between the questions. Same body is this person is just his body, so there'll be no difference.
with like the question about human persons and minds or whatever,
Yeah.
or human bodies or human persons. I should
Or
say.
yeah, human bodies versus persons,
Yeah.
or
In both cases,
or minds, right?
Yeah.
So minds are like persons.
Yeah, in both cases, it seems like there's a persistent principle, like a persistent principle of growth and change, or
But they're not. But that's not clear they're the same principle.
right, or the persistence of mental phenomena that we can identify.
So John Locke would have said that in the case of persons, it's the same person when it's the same consciousness, but it's the same body when it's the same life. physical life, or what Aristotle might have called the vegetative principle. Aristotle said there were three essences within any human animal, whatever. There was the soul, the rational soul, the perceptive soul, and the vegetative soul. So by vegetative, he didn't mean like plant-like. He meant the just the core life principle of organic life, which need not involve perception or rationality.
Can you reiterate that point about Locke you also said?
Locke?
Yeah.
Yeah, Locke says that you have the same life in the case of, say, a plant that's the same on Monday as it is on Tuesday, even though it's changing its parts.
Would that also tie in with the ship of Theseus? But it's
Well,
an
it
inanimate
does.
object.
The question is whether the ship of Theseus really applies to living things or not.
Yeah, that's the question I was curious about.
Yeah, it certainly applies to inanimate objects, though. So we can bracket aside the question for the time being of whether it applies to living things. Maybe it doesn't.
Right.
Because it seems like the principle of living things themselves, their nature requires incessant change of parts through the concept that it's essential to life that there be metabolic activity. And what is metabolism?
Change.
Metabolism is, I would say, change of parts powered internally by the thing itself. It's not just that it changes its parts. We can change the parts of the ship. In metabolism, it's the thing itself that powers its own change of parts. So it causes itself to constantly change it. Right?
Right.
Yeah, so that's very different than a ship where the change of parts is imposed, say, from the outside. In the case of a living organism, by its very nature, it must change its parts in order to live.
Yeah, depending on temperature. Or
Well, it must. It must
hunger,
eat.
everything.
It must eat and bring.
Observe nature.
It must bring in oxygen and excrete waste and constantly change its parts. Not just its properties, but its parts.
So the parts would be like, for example, the plant is growing and then it has more cells, right?
Yeah.
With sunlight. it
Creates
grows
new
more.
cells and sheds old cells, and we do the same thing. So all living things are like that.
And with animals, it's like temperature can change as well. With
Yeah.
blooded animals.
Yeah, that's part of the metabolic process. Yeah. So metabolism is a thing that all living cells do, whereby they take in nutritious molecules and convert them into energy, and then create new molecules out of that. And so on. There's a whole cycle, a Krebs cycle, and many other biochemical processes that power the living organism. Plants do it through photosynthesis, so they don't have to take in nutrition, right? They get their energy from the sun and convert it.
In the case of Theseus,
Yeah.
isn't there a direct relationship to the history of the vessel and the identity of the vessel, irrespective of the parts?
This is an inanimate object, right? The ship.
In other words, we value antique vessels based on their history.
Yeah, so if you were asking, great point. So if you're asking about which is the original Nina, Columbus's Nina,
Oh, yeah, yeah.
I think you're going to go with the one that's made out of the discarded parts, right?
Direct.
I mean, it's going to be, it's going to be the one that has the original stuff in it. You're not going to want some like vessel made out of brand new parts, right?
It's just an imitation.
You might say. But on the other hand, if it's the one that, I mean, still, if it continuously evolved from
The
Columbus's
history.
Nina through that history,
It could be, yeah,
but you can't have two Ninas, so you're going to
right, right.
you're going to have to choose one as the authentic Nina, or say that neither of them are.
But isn't that
Right.
the metaphysical principle that
So
the
it's a
value-
problem. It's a
It's a
problem.
problem?
I mean, I think ships, the identity of ships, what this shows is that the identity of ships is problematic. that they may not have any
Real identity.
or real existence then.
That's right.
All right, let's move to a related problem. The problem of increase, which is connected to questions also about how things can change their parts. Here the question is, how can an object or inanimate thing grow bigger? So we often say that various inanimate objects increase in size. Maybe you have a house and you add an addition to it, like a room gets added on. Then you can say my house is larger than it was before. I had a 3-bedroom house and now I have a 4-bedroom house. So suppose you have this object A. How can A get bigger? Well, you might say one way for something to get bigger is for it to be stretched. Like if you have a person, they might get taller by being put in the rack and like stretched. Right? Like this person was 5'6", but now they're 5'8" because they've been in the bed of Procrustes, and they've been stretched. So, aside from stretching, right? Leaving stretching aside, how can something get bigger? So we don't want to consider stretching here, because that's a very particular and special case. And generally things don't get bigger by stretching.
Well, there could be an increase in volume that doesn't imply a change in parts, which is kind of like stretching, but doesn't seem quite the same. You know, what's that thing called?
Pufferfish?
Oh, well, yeah, but they take on new parts because or should they? I have no idea.
No, they just blow themselves up. But that's stretching.
That's stretching.
Yeah.
Yeah.
Or like when something heats up and gets more volume.
Or like ice that gets bigger when it's frozen.
Yeah.
Like water specifically, when it gets cold, it increases in volume, doesn't it?
Yeah, ice increases
Yeah,
in
but
volume.
it's weird because at 4 degrees Celsius it's densest. So when it goes up from that, it gets bigger, and when it goes down from that, it gets bigger. Water is really weird. But yeah, changes in volume are a way, through the rearrangement of parts.
Right. Yeah. How can a thing get bigger through the addition of parts then?
Yeah, if it has its parts essentially, it doesn't seem like it can.
Right, so that would be one way of putting the problem. How can a thing get bigger through addition of parts?
Are you only talking about the addition of parts?
Yeah.
Or you, okay.
I think so, yeah. We don't want to consider these cases like stretching or the volume increasing because it's heated. Right?
Right.
Those seem not the cases we want to focus on, but how did the house get bigger?
Addition.
Yeah, and by addition, right?
Right.
Yeah. All right, so this is the problem then. It seems like the only way A can get bigger is by adding something on. So then you get, well, by addition. So you have A, and then you put B on there, that's the addition. Okay, so you say that's how it got bigger. But what got bigger? question. Did A get bigger? A is exactly the same size as it was before, right? A didn't get any.
The meaning of A?
Well, A didn't. Here's A, right? It's still there, and it's exactly the same size as it was.
The entity which has A as a part.
Right, so A did not get bigger, right? We agree, right? A didn't.
But when, like, for example, one B is like a sunroom, and it, like, you took down the wall within A, so now A needs to seem to be one figure.
Yeah, but A didn't get bigger, right?
No.
A didn't get bigger. And did B get bigger? No, it didn't get bigger either, because before B was like over here, and then we attached it over there, right? So it didn't get it. It's still the same as it was too. So B didn't get bigger. What about AB? Did it get bigger?
It's a new thing.
Yeah, it didn't exist before. So if it didn't exist before, it had no size. And the only way something can get bigger is if it has a size and that size increases. So since it didn't exist, it didn't get bigger. AB did not get bigger because it didn't exist previously. So the question remains: so what got bigger then? It's puzzling. If it wasn't A, B, or AB, it seems like we're forced to say there's something else that got bigger. In that case, we have to say what that is and what its relationship is to AB.
Right.
Yeah.
Well, yeah, I could say something like, I probably couldn't say A didn't, get bigger, A can't get bigger. But I could take like an entity X, which is any entity that has A as a part. Maybe X got bigger. Was that a possible solution?
Yeah, well, there could be something that got bigger, but I'm just saying we have to say what that is
Right.
and how it relates to AB.
Right. Well, yeah,
That's all.
X being like any entity that has A as a part.
Well, the entity that we're talking about is a house.
Right.
So you could say my house got bigger.
The house as a whole would have gotten bigger, but the pieces wouldn't.
Yeah. So you'd have to say my house got bigger?
Right. If my house is equal to A, then the utility of A got bigger.
My house got bigger. Okay. Then what's the relation between the house and AB? Right.
Identical.
Can't be identical to AB.
Right.
Because if it is, then we're just back where we started with. AB didn't get bigger. So since AB didn't get bigger and my house did get bigger, according to the theory that something got bigger, because you can say nothing got bigger, right? Which would be puzzling, of course. But if something did get bigger, it would have to be something other than AB. So my house, therefore, is not identical with AB. And then it follows that we have two physical objects in the same place at the same time, my house and AB. So it's gotten much more crowded in my house than it was before, because we have two things in there at once.
Right.
Okay. So my house got bigger, but my house is other than AB. So what relation does my house have to AB, other than being a different thing than AB? Exactly what connection is there between the two? It seems like it must be a very intimate relation, since it's very hard to tell them apart. When you look at AB, you think you're looking at your house, and vice versa. So it seems they share a lot of the same properties. right?
Right.
Like AB weighs a certain amount, but my house weighs exactly that same amount, right? As AB weighs. It seems like if AB is hard, then my house is hard. If AB resists the rain, then my house resists penetration by moisture. It seems like they have the same, a lot of the same properties. Do they have all the same properties?
Would dimensions be a property?
Yeah, size. Yeah, they would have the same square footage. They would have everything. One difference is my house can exist without AB, right? Because it existed without AB before B was added on. But AB cannot exist without AB. So there are some differences, but they seem to be modal differences about what might be true at other times or what could be true. But at that very moment, their properties seem exactly alike. It's only these properties referring to other situations where they diverge. So what's the relation anyway between the house and AB?
If the house doesn't have its parts essentially, then it would have to have some other thing that, you know, makes it what it is, that persists, such that it's the same house.
Yeah. Well, if we say the house has its parts essentially, then
it couldn't increase.
then it couldn't increase or
Right.
decrease, right? So that's the doctrine of mereological essentialism, which says that a compound thing has each of its parts necessarily. This is called mereological essentialism. Which is basically the idea that parts are essential to the whole. A part is essential to the whole. So it would say that anything that has a part cannot be the same thing if you remove that, detach that part from the thing. So if a table has 4 legs as parts, then if you remove one of those legs, the table no longer exists. It's just a part of the table that exists. You need all the parts of the table for the table to exist. If you remove any of them, it's destroyed. Even if you remove only a tiny speck of wood off the edge of the table that you scrape off using a penknife, it's not the table, and it's a different table. That's what the mereological essentialists would say. So that's one way out of the problem, is to say that you can't, nothing ever does grow bigger through the addition of parts, or decrease through the removal of a part. But if we say that things can grow or diminish through the addition or removal of parts, respectively, then we're mereological inessentialists.
Innocent.
Yeah. And then we're, it seems, stuck with the fact that you can have 2 different things in the same place at the same time, both of them material. Which,
Does the word mirror come from the author or?
Mirio.
Mirio?
Yeah, it comes from the Greek meaning part. Yeah, Mirio means part. M-E-R-E-O. That prefix has to do with. Meros in Greek means part.
Part.
M-E-R-O-S. Ancient Greek. Yeah. Right. So should we accept that there are 2 or more things in the same place at the same time, or should we go with the mereological essentialism doctrine?
But we'd have to find a thing that, like that persists in the house, it would seem, such that it's such that it's its own thing and not just A, B. And I'm not sure what that would be.
No, there isn't.
Foundation.
Right.
Yeah, but it too could become rotted and be refurbished, right?
It's
Like
the
they
same.
jack the house up and they put a new foundation.
Oh, yeah.
Because the old one is like cracked. And you need a sump pump and like your living room is like tilted. And
Floors will-
yeah, you put a marble in there and it keeps on going, right? Yeah. And then you have to jack the house up and redo the foundation, or termites consume it. And
Don't you say the location of, or just the entity or the concept of the house is what matters?
yeah, well, it
Yeah,
seems
mine-
kind of like that.
Mind-dependent object.
Yeah, seems like you get to the mind-dependent object thing. But then in what sense is it really a material object if it's mind-dependent?
And
So, I mean, that's sort of one way to go, but it doesn't seem to do justice to our original idea that the table's a material thing. So, that's kind of a question. A lot of people say that AB constitutes the house. So the house is constituted by A on Monday, but by AB on Tuesday. So on. What exactly does that mean, though? And why should we say that the house is constituted by these different things at these different times? I mean, it seems like in the end we have to make the house some kind of conceptually dependent object. Would things like houses exist without humans anyway? It doesn't seem like they would.
I mean, don't birds have nests?
Yeah, but birds also have a purpose too. So, I mean, birds have some form of cognition also.
Oh, so you're saying material things would not exist, such as houses, if cognizant creatures did not exist?
Yeah, and birds would be among those creatures. Yeah.
Okay.
Why wouldn't they? They have a language. They communicate, right?
Yeah.
They have a language. They have purposes. Seems like they do. As much as we do, though we have more developed, perhaps, cognitions than
I mean, even
they
like
have.
bacteria seems like it might not need to have its parts essentially. With a consistent principle of, or a principle.
But that's a living thing. That's
Right.
a living thing.
Yeah, or like, but it exists independent of cognition.
The bacteria?
Yeah.
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 Oh, yeah. Yeah, but it's it's not an artificial thing.
Right.
Whereas houses and tables are, it's hard to see how they would exist without cognitive
Or made of
activity. And I'm including nests in there because they're creations of birds for bird purposes like shelter.
So what about like planets and solar systems?
Well, solar systems don't have any.
Yeah, but there's still things that are like made. So like the moon, for example, was made by
Well, it's,
like,
yeah, it's made by other physical.
yes, but they're not
Things.
cognizant things.
No. Right. So, I'm saying if you're a mereological essentialist, then you'll say that these things are ever changing. Planets and moons and solar systems and galaxies, right? So, they do exist, but they're in a constant state of mereological change, and so they wouldn't be the same entities from one moment to the next if they gain and lose parts. Right. If you want to say somehow that they are, then you're going back to the human conceptual scheme to say that, and you're positing some kind of cognitive construct here. I mean, according to this line of thought, they'd be no different than the table. They're not artifacts, of course, right? But it still might be that you're conceptualizing them in a way parallel to the way that we ordinarily think about objects, that they can continue their identity through change. If that's not the way we go, then we have to posit this constitution relation and say that it's a metaphysical relation that's independent of the human mind, and that these more complex things, whether they're tables or galaxies or planets or right, whatever, somehow emerge out of these parts and then assume a kind of identity of their own, a life of their own. And so that, then you might say, independent of any minds, like the sun remains the same
Or even
thing over time, right? Even though it's gaining and losing parts, it's belching out
neutrinos.
all kinds of magnetic, right, and flares. So it's changing its makeup, right?
The sun is super volatile. It even has like
Yeah.
moods.
Yeah. So if you want to say that it maintains a strict identity, right, then it's going to be a thing that does decrease and maybe sometimes increases if some asteroids get sucked in by gravity and become part of the sun, right?
Well, the sun on its own, like people don't like scientists don't understand, but for some reason the sun sometimes gets colder. It gets these like dark cold spots, and then sometimes
Yeah.
it gets brighter with the solar flares that you were talking
Yeah.
about.
Yeah. So it's changing its parts over time, right? So if it increases or decreases by addition, then it's gonna be like the house over here, right? In that respect. And you're going to have to say that the sun is constituted by different blobs of matter at different times,
And the principle-
retains its identity through this constitution relation. The puzzle is, what is this constitution relation, and why should we suppose it exists when we can just say that there's matter there? I mean, it's sort of clearer in the case of ordinary artifacts because we imbue them with a purpose. And to that extent, they're mind dependent. It's very hard to see in the case of the non-mind dependent ones, like the sun. Very hard to see why in the case of a mind independent compound object, why these entities would supervene or emerge out of the raw matter. It's hard to find any foundation in nature for such a belief, but it would be an area that could be philosophically explored and defended by those that have that intuition. They might appeal to certain natural laws or processes, perhaps, as providing the continuity that grounds the identity of these objects. They form a kind of continuing system, maybe, or something. Right?
Right.
So it's not hopeless. But there's a basic issue with having multiple physical objects in the same place at the same time, which kind of undercuts, militates against, or pushes against those kinds of views. And it would be simpler just to say, well, there's the matter there, and that changes, and when it does, you have a different material object. The sun is different every day, as Heraclitus said of the river. Each day you step into a different river. Each day the sun is born anew. I think he said that also.
Characterizing it as a system
Yeah.
seems like characterizing it as an event.
It doesn't have to be. It could just be a system a system of particles that follow a law. That's all I mean by a system here. I mean, it could be an event, but I don't see any reason why one would say that. Why not just say it's a system of objects that obey certain laws?
Yeah.
It seems to me simpler just to say that you have a different object. Because it's very vexing why you would have two physical objects co-occupying the same place.
For the river example, wouldn't you just fall into like, I forget what ancient Greek philosopher said that like the one constant thing is the constant
Yeah,
change.
Heraclitus. Yeah.
Yeah, with the river, could we just accept that the two houses are not the same house at all?
Yes. Yeah, that's the mereological essentials.
Oh, okay, yeah.
Yeah, the two rivers are not the same, the two stars are not the same.
So like every time that the sun, every second the sun changes, it's a different sun.
Yeah,
Every time you add to the house, it's a different house.
yeah. If you follow that consistently, though, you're going to have to say that every time you take a breath, you're a different person, or at least a different organism. And we don't want to say that, I don't think. So that opens the door to the view that if a system is highly complex and organized, then it can endure through change, through mereological change,
Right.
which I kind of favor in the case of living things. There's a big difference between like the sun and a living thing. But in each case, there's an enduring system of changes that is very stable.
Right.
And we talk about like as I guess a metaphor or a analogy, the life of a star, the life cycle of a star. I'm not saying that's anything like the life of a carbon-based organism. It's not, clearly. Anyone who argues that it is, I think, is being very sloppy. But there is still an analogy, which is that there is a cycle of events that falls under laws. So there's at least that in common between the two. These events involve objects that are interrelated in certain ways.
So would you be prone to say that, like, for example, if you were talking about this, so like you would have to make a distinction between the life cycle of a star and then the life cycle of a carbon-based organism, and both of them, could you say that the carbon-based organism is made up of objects such as like atoms?
Yeah, it's made up of the same
More.
objects as a star is. They say we're all made of stardust, actually. So.
Yeah.
Yeah, so we're all made of the same kinds of parts,
So that
but
distinction is important.
it can be important. One has to examine all of these cases and see if there's a plausible way that organisms can retain their identity through change. And then one has to examine the case of stars and see if there's a similarly plausible case that can be made for them. But we don't really have any folk ontological basis for pronouncing on the identity of stars. But we do in the case of ourselves, because we have a direct experience of self-identity in the case of ourselves. We have a firm belief that our life lasts more than a second, and that the life that we exist today, we existed yesterday, and we will exist tomorrow, even though our composition may have altered slightly. We don't have that kind of data for the star, right? We don't know. There's not as much at stake, is another way of putting it. There's really nothing of great moment at stake as to whether the star is numerically the same star or a slightly different star or whatever. But there is something very important at stake as to whether we continue to exist from one moment to the next. So let's turn to the case of organisms, if that's agreeable to everybody.
Sounds like a good transition.
Yeah. So there are three big questions about carbon-based organisms, which are the only kind of organisms we know. though we might discover other kinds of organisms someday. We can only really talk intelligently about organisms that we actually know to exist, have some knowledge about, and those would be organic life forms.
Carbon-based.
Yeah, organic life forms, whether animal or plant or fungi or whatever, bacterial. So there are three big questions about these organisms, I say. First, what are organic living things? This is a definitional question. Can we define a set of properties that single out these things from among all other things in the universe? So I would say that organic living things comprise a natural kind or category. They fall in the same group. They all have something in common, which is their composition. They're made of carbon and nitrogen. These,
Carbon, nitrogen, oxygen.
yeah, these what are called organic macromolecules. Carbon has some special features that allows it to form really large molecules. It has to do with the kinds of bonds that, covalent bonds that carbon has.
The most valent electron.
Yeah, at least under these kinds of temperatures, carbon's the only molecule, element that can form such long molecules, some complicated molecules, that have a high degree of chemical reactivity with other molecules of the same sort. So you get these mind-bendingly complex organic molecules that can form, like DNA and RNA, which have fairly magical or miraculous or astounding properties to duplicate themselves. And to carry information as well, like RNA. Right, so question one is, we said, what are organic living things, which is a definitional question. And then another big question is, what is the principle of identity for these things? And third, what is their principle of compositional unity? That is, in virtue of what do all of the parts of a living organism hang together to form a living organism? Okay, so if you have like a dead organism,
Okay.
like a crushed bug or a dead cat, there's some relation that holds among the parts of that thing when it was living that no longer holds among those parts. Right. And it's that relation which is the principle of compositional unity for that living thing. It loses it when it's dead, but it had it when it was alive. So what kind of principle would it have to do with? Does it have to do with each part being rigidly attached or bonded to every other part? Like, say, in a house, all the parts are rigidly attached so that they form a sound structure. Do you find that with a living organism? Well, some of the parts, like bones, may be like that, but there are lots of other parts that aren't.
Interactive.
It's somehow interactive or functional. So it has a lot to do with the function of all of the parts, not just their attachment. Inanimate objects have a compositional unity that's more related to attachment or joining of each part to another, whereas living things seem to have a functional principle of organization. So what is their principle of compositional unity that unites all the parts into a living whole? Okay, so on the definitional question, basically, you can say that a carbon-based living organism, first of all, has a layer, is surrounded by a layer or a membrane made of organic molecule, big organic molecules. And it can absorb and excrete through the layer or membrane. Right, so you have these membranes, and right, you breathe, right, air comes in. Okay. The organism can metabolize these molecules. So the coronavirus, for example, has no metabolism. Therefore, it wouldn't count as a living organism.
Yeah.
It's like a vicious parasitical chemical. It's not a
It's like a
living.
computer virus.
Yeah, it's not a living thing. Okay. The organism can synthesize molecules. So not only does it metabolize or change its parts, but it creates chemical compounds as well. Yeah, and it's by means of the activity of a what I call a nuclear part. And a nuclear part is a macromolecule that can copy itself, like DNA or RNA. So the DNA or RNA orchestrates synthesis. It gives commands which are carried by RNA to proteins, which then assemble into these macromolecular parts. And then there's a circle of causal activities. So absorption and excretion cause metabolism, which all of that then causes synthesis. All of that then causally contributes to absorption, excretion, and metabolism. So you go around and around. All of the processes contribute to each other. Yeah, it's a cycle. And these are the basic activities of living things: metabolism, biosynthesis, absorption, and excretion. And viruses don't do any of them. What about reproduction? What is that? Can we say that every living thing can reproduce?
What about like mules?
No, they can't. Not every living thing can reproduce. So we can't just put reproduction in as a condition. We can say, though, that every organism will belong to a natural kind of compound individual thing which can reproduce. So in other words, even though mules can't reproduce, they belong to a natural kind which has some other members that can reproduce, like other living organisms. So taken as a whole family or as a tree of life, reproduction characterizes that natural kind, even though it doesn't characterize every individual in the kind of living things. Yeah. And finally, an organism may not be a part of something that meets all these conditions. In other words, organisms don't have to be parts of like some superorganism. They're autonomous. So any organism you pick is possibly not a proper part of some like bigger system. It may just be its own organism. Okay. that distinguishes it perhaps from non-organism parts of living organisms, like blood cells, which are not organisms. Still alive. They're part of a bigger system, but like we aren't.
Like antibodies?
Yeah, or anything like that. So, point is, living organisms, in and of themselves are not themselves subservient functionally to bigger systems. They're freestanding, free-living things. And so you might dream up some case where it becomes subservient, but it's not necessary for it to be. All of us exist, and we're not part of a bigger living system, a bigger organism. All right, so those are the main characteristics of carbon-based organisms in terms of which you can define what a carbon-based organism is, I think. Okay, organism identity. I'm going to say the following theory, that every living organism of the carbon-based kind has a special part within it, which is vital and controlling, which I dub the master part of the organism. So every organism has a special part. This part controls or regulates the biological functions of the organism. In the case of humans, it's the central nervous system. In the case of, say, a paramecium, which is a microscopic protozoan organism, it would be the nucleus of the paramecium. So that's like its brain.
Okay. Like for bacteria, the nucleus, for humans,
Yes.
your brain?
Yeah. And for a slime mold, it would be a whole system of nuclei, because the Plasmodium slime mold has thousands of nuclei in it. But all the nuclei communicate with each other, and they form a nuclear system which manages the organism. So, yeah. There's always a master part. Blue-green algae, which are very simple eukaryotic bacteria, algae type things, don't have a nucleus, but they do have like a privileged nucleoid, which is a particle of DNA, which
And they're subservient.
which tells the proteins what to do. It sends out RNA to communicate. Yeah, so they call that a nucleoid, because it's not quite a full-blown nucleus, but it's a nucleoid. Yeah, it's basically a strand of DNA that runs things inside the primitive cell. Okay, so my principle of organism identity that I'm going to hypothesize is that an organism 1 at a time 1 is identical with an organism 2 at a time 2, if and only if O1's master part at time 1 is identical with O2's master part at time 2. So basically, the identity of the organism is determined by having the same master part. So for example, if you had a caterpillar that turned into a butterfly, you could say it was the same organism because the master part stayed the same through that transmogrification from caterpillar to butterfly. The nervous system of the insect would be the same in there, even though it completely changed how it looked from a worm to a beautiful flying beast. It's also possible to remove the nucleus of a cell, if it's a single cell, and put it into it's possible to swap the nuclei of cells And if you do that, you swap their identity. You cut out the master part of this one and put it in that one, and take out the master part of the other one and put it in the first one. Then you've just swapped the identities of the two cells. Or consider this example. Suppose you have a plant, right? What would the master part of the plant be? It seems like it's very decentralized in the case of a plant. It might be the roots, but it seems like the roots won't regulate all the functions of the plant. And some plants don't have roots.
Would the seed itself maintain a continuous identity?
No, because it changes immediately.
Yeah, it seems like you have to say that the master part of a plant is extremely decentralized, that it consists of the whole plant except for its sap. So the sap does not control everything. It's the structure of the whole plant that regulates that whole system, which includes the sap. That the sap is like the least functional part of the system. But if you drain the sap of a plant out and replace it with the sap from another plant, it seems like you still have the same plant because you have the same master part.
And so it's decentralized because every nucleus
Yeah,
in those
plays a
cells-
role.
Yeah.
Yeah, except for the sap, which has no nuclei in it.
Because it has no-
It's just like juice, right? Sugar water floating around it. Maple syrup, right? Which has no regulative function to it. But all the cells contribute to the regulation of the entire plant. Now the plant also, produces hormones which are regulative as well, like plant growth hormones and things like that. But those are controlled. Their timing and release is controlled by the overall plant.
System.
Yeah, by the system. Yeah. So, another example is like Siamese twins. So Aristotle thought that the master part of an organism was its heart. He thought every organism had a master part, but he misidentified it as the heart rather than the brain or nervous system. So he thought that if an animal had two hearts, then you had two animals there. Yeah, you had two animals there, which was a mistake. So he proposed it as a criterion for distinguishing between an animal that had extra organs as opposed to an animal where you really have two animals as opposed to just one. Okay. But once we realize that the central nervous system is the master part in an animal, right? Then we can say that if we encounter like a two-headed turtle, right, which is basically a Siamese turtle, that you have two turtles there there are two different brains and two different nervous systems. Yeah. So one nervous system is this one and the other one is like that one. Right, there are these two spinal columns that are sort of scrunched together, but they're still separate.
Same with snakes.
Yeah. But if you have, say, two hearts, then you just have a genetic defect, but you have one organism that's born with like two or three hearts. It's a birth defect. But there's just one organism because there's just one master part. But if you have two master parts, then you've got Siamese twinning. It might look like one organism, but actually it's two. So there are two different master parts in the organism. In the organisms. Right. So that's the principle of organism identity. Now you may say, how do we know when we have the same master part? Well, sometimes we may not know, but in other cases we clearly do know. So, but that's an epistemic question. Can we always know whether the master part is
Like
present?
the plant.
Yeah, we may not know, but that's okay because a lot of the time we do know. But it seems to be a metaphysical truth about these things that all their parts can undergo change, so the master part can change as well and still be the same master part. We don't have a criterion for their identity.
The thing that's interesting about the master part is that for a second I was like, you can't take out someone's heart, but you can replace it with an organ donor's heart. So that does seem pretty correct.
Yeah, and what if you try to take out the central nervous system?
Yeah.
You can't replace someone's
You'll
brain.
kill it.
Yeah.
Yeah, it's over.
And if you do manage to replace it, then you don't have the same organism.
Different person.
Different organism.
I wonder if there's like a study of like,
It would be a different person if the person is definitely the organism,
Right.
which it probably is.
I wonder if there's like a study where they swap the brains of 2 rats and see if that
Yeah.
would heal and survive.
Yeah. All right. So, what are the basic notions of a master part? Okay. So there are 3 elements of the master part. One is that it's vital. The other is that it's necessary, and the third is that it's controlling. Okay. A vital part of an organism, okay, is a part which has a function. Okay. So one of your vital parts is your heart, like you just observed. So why is the heart vital?
Because
This-
I thought you would die.
Well, it's a little more complicated. It has a function such that without something performing that function, you wouldn't last long,
It's
Yeah.
necessary.
right? But it doesn't have to be that heart that performs a function. It could be a pump or,
You could have like an electronic one.
yeah, whatever. It's the function that's vital. Right? And the heart performs it, but if you can replace it with something else to perform it, you can still survive. Okay? And yeah, you can't live for long without that function being performed by something. You might only live like a second.
Or even like a pair of lungs. Like you could have like
Yes.
facilitated or like
Yeah, same thing. Those are vital organs, but they're not necessary organs. A necessary part is a part such that your being alive entails that you have that part.
you must have that part.
Absolutely. Necessarily to be alive. Without that part being part of you at time t, you won't be alive at time t. So if we cut off your head, you won't be alive anymore. At that time, instantaneously. So there's no lag in time. Whereas in the case of the heart or the lungs, there is some lag. If your heart was removed, you wouldn't instantaneously die. You might have a second before your brain still had enough oxygen that you were still conscious, and then you'll immediately die after that. But if they cut off your head, you're dead at that instant. Right? It's instantaneous because the master part has been. All right. And finally, what is regulation? What is this regulatory activity?
So that's controlling.
Yeah, what does that mean? What does it mean to say that it controls? Okay, so your bodily parts have all these functions, like metabolism and all these things. They have to occur within certain limits. They can't be like too fast or too slow, or too hot or too cold, whatever, right? It's like the porridge of the 3 bears, right? It's got to be just right. And for all these things to be just right, they have to occur within certain limits. And the master part keeps those activities within those limits. So it makes sure that your metabolic rate and your heartbeat and your blood pressure are never too much or too little, but are always in the range of what can keep you alive.
Yeah. Or like,
So it wouldn't let your heart, it functions to not let your heart drop to like 1 beat a week or whatever it is, right? Because you won't be able to live. We don't know where those exact limits are, but they're somewhere, right? At some point, if it's too slow or too fast, you're going to die. The heart can't go too fast and it can't go
Blood pressure.
too slow. Blood pressure can't be too low, but it can't be too high. So the master part works to keep every bodily function within those 2 extreme limits.
alright.
Some range in there that's not the biggest, the total range. What exactly that is can vary from one organism to another or from one person to another. So that gives you an explanation of how regulation works. That turns out to be a well-understood notion
So
rather than just a metaphor.
an example of regulation could be like, I know that there's a certain region of the brain that controls like sleep and wake functions.
Mhm.
And if you get like hit in the head in that specific area, your sleeping and waking cycle would be disrupted. Would that be a good example of this
Yeah.
regulatory control?
Sure. Yeah, and they say that if you look at the brain, you can see where the control is for all the different parts of the body. Like there's a part of the brain that controls the liver function and kidney function and breathing and heart and all these different things. All right, so on that note, we'll call it quits for today. And we'll pick up next time. Thank you very much.